Good afternoon, all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today I am going to take the topic on Moore and Mealy machine under the unit sequential circuit. So this comes under the subject Digital Principles in Computer Organization. So before moving into this lecture, so kindly go through my previous videos to have a recall on what is sequential circuit and what are the type of flip-flop. And in the previous video, we have discussed about registers and its type. So we had seen introduction to registers and the types of registers, how do the shift registers work, and the application of registers. So type of registers: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out registers. So today we'll have a topic for discussion on understanding the sequential circuit and how we are going to design the sequential circuit, providing the importance of the finite state machine, and ending up with a comparison of the design models for the sequential circuits. First, understanding about the sequential circuit. So how do we begin with the design concept of the sequential circuit? As you people very well know that sequential circuit is a combination circuit combined with a memory element inbuilt in that. So a memory element include a flip-flop, right? So a memory and feedback, it provides a necessary design for the sequential circuit. So when the memory is being added in the circuit, so we could find a fine tune to obtain the output. And this is being used in the real life examples of elevators, traffic lights, and vending machines also. So this is how it gets difference from the combination circuits. What is the importance of the finite state machine? So this finite state machine is important as we are going to see the design of the sequential circuit based on the finite state machine. So finite state machine is a design which provides on what condition the design are to be implemented. Say for example, if the output is to be dependent on the input, or the input and the present state, or only the present state. So we have a confusion on where to have the design part. So this finite state machine, it gets split into two. One is a Mealy model, the other one is a Moore model. So in Moore model, the output here, it solely depends only on the our current state as such. And we are going to design based on the current state what we are feeding, and when there is a change in the input as well as in the current state, then we go into the Mealy model. Since the Mealy model output depends upon both the current state and also the input condition, and hence the Mealy model is little complex to design, whereas Moore model, it solely depends upon the current state alone. It has a simple design and analysis also. So going with the state machine basics, what is a state machine? So state machine consists of a memory element of the past data and also the input, where the output depends upon either the state, present state, or the input, or the combination of both, it depends. And the transition is being triggered by the inputs after providing the necessary clock pulse. And what are all the tools you are going to design is based on the state diagram and excitation table. We are going to design this machine. So first let us see about the Moore machine. In Moore machine, the output depends upon only the present state. The advantage of this is it has a stable output and simple timing as such. Since it depends only on the present state, it doesn't worry about what is the input condition, what are all the predictions that could happen. And this is being used in the real life examples of a traffic signal controller. And next, focusing on the Mealy machine. The Mealy machine, as we previously said, that the output depends upon the present state as well as the input. So when there is a slight change in the input, it gets reflected by the time within the application of the next clock pulse. The changes has been reflected in the output side, and hence even though Mealy model is a complex in design, whatever changes in the input, that is being reflected then and there in the output side at the beginning of the next clock pulse. And advantage, it has a fewer states and it gets a faster response, and hence this is very quick in detecting the sequence. So that's why we are using this in the sequence detector. And we are going to have a comparison of a Moore and Mealy model. Moore model, it has a stable output since it depends only upon the present state and not on the input. It has a stable output and more number of states are there, and it is in sync with the clock pulse what we are applying for the particular flip-flop. Whereas in the Mealy model, it has a faster output since it depends upon both the present state as well as the input. Here the fewer states are being implemented, and this is where the case sensitive for the input. When there is a slight change in the input, it is being reflected in the output, and hence this has been compromised based on the stability and how quick it has been responding to the signals what we are giving. And Murray's best example is the traffic light controller, where the status of the current scenario, whether they have to stop or they have to wait or they can move as such. So it depends upon the current state alone. Whereas in the case of a melee machine, it depends upon the input as well as the present state, and this is a good example in the case of a vending machine, where it first wait until the coin is being inserted, and then it depends upon the state and what you are choosing in the option, right, at that time input. So it depends upon the state as well as an input, and then it gets dispensed in the output in the vending machine. So this state diagram shows how the transition has been happening in the Mealy model. And let's summarize. So we have seen about what are all the type of registers and the sequential circuit, how we are going to design based on the finite state machine, either Mealy or the Moore model. Now the activity is for you. If two finite state machine they produce the same output sequence for the same input sequence, how will you determine whether they are the Mealy or the Moore machine? So we have to consider whether the output is depending upon the current state or the current input, and accordingly we will design whether it is a Mealy model or the Moore machine. And the assessment quiz have been discussed along with the answers here. So kindly go through. Thank you.